All right, so here's my first Julie notes for just some of the review stuff. First thing I want to talk about, so number 1 is distance formula. If you have things that are on the same line, so to speak, you could just count, right? 1, 2, 3, 4. Or going up and down. If it was from 0 to 3, you could just go 1, 2, 3. The problem is when you're on a diagonal, because of Pythagorean theorem, if this is 1 and 1, square root of, 2 is the diagonal, which is about 1.4. So if I have, say, a point over here at -2, -1, so -2, -1, and maybe a point at 3, 1, and I want to find the distance between those, right? It's at a slant, and it doesn't even go nicely through the hypotenuse of like that I know is the square root of 2. So that is a problem. So what you could do, and if you forget, if you're like, oh, I forgot how to do these, try to use good problem solving skills and just draw in a right triangle and then go, oh, I could use Pythagorean theorem. So you could go 1, 2, 3, 4, 5, and then 1, 2. And so then we could do Pythagorean theorem. So if this is 5 across, you could go, okay, 5 squared, and then you could go 2 squared, and that's what, 25 plus, what is that, 4, hopefully, 29, and square root of 29. And again, if you wanted a decimal, you could square root that. But that would be what your c squared is that. And so when you square root both sides, right, that would be your c, and you could do it that way. Okay, now there is a formula because if you think about it, this is the change on your x. This is the change on your y. So the distance formula is really, you're doing Pythagorean theorem, so you're doing a squared plus b squared. We give them different names. And then you square root it to get the distance. And so the change in x squared and the change in y squared is your a and your b. And again, sometimes if you see this formula, they might do like x2 minus x1 and y2 minus y1 squared, because all you're going to do is be like, how far apart are those? How far apart are those? So if you look at what were my original points, -2, -1 was my input and output, and 3, 1. Okay, so the change in my y is going up by 2, right? So that's 2. And if you do a -2, it doesn't matter because when you square it, it's going to be positive anyway. And then what's my change in my x? Well, it's going up by 5. So up by 5 squared. So you still get the 25, you still get the 4, you still get the square root of 29. So this formula really is just Pythagorean theorem. So that's kind of up to you as far as like, oh, okay, whether you want to think about it like that or not. And of course, I cannot find my lovely list of the things I wanted to cover. I'm going to pause this for a second here. Okay, so the second thing I wanted to talk about is exponent rules. Just a quick reminder, if you have something like this, and I probably should use smaller numbers, but that's okay. What you're doing is counting. You're literally counting x8s. Let's see, 8 x's. There's 1, 2, 3, 4, 5, 6, 7, 8. And then 10 more. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so you're counting how many of those factors you have, which is 18. So the reason when you multiply, you add is because you're counting. And if you remember as a little kid, how you learn to add is by counting. And so adding is counting, okay? If you have a power to a power, something like that, okay, this is 2 sets, if I could write 2, well, maybe I can't write today, 2 sets of this. So if you write it twice, then you could see, oh yeah, I do have 6 of these, I do have 6 of these, so I have, what, 12 of them? And so if you notice, you can multiply these. And the reason is you have a power to a power, so you can multiply because you have 2 groups of this. And think back, and as a little kid, if you had 2 groups of 6, that is the definition of multiplication. So 2 sets of 6 is multiplication, so 2 groups. So that's why when it's power to power, you multiply. And then the last one is division. If you have something like this, okay, if I write out my 10 factors, and then my other 2. When you're dividing, you can cancel factors. And again, these are all multiplied. I'm not writing every single dot in there, but these are all multiplied. So when you cancel, you're getting rid of stuff. That's subtraction. So the exponent rule here would be to subtract. And again, that should make sense because as a little kid, if you had 5 and you took away 2, you subtracted. Okay, so when you cancel things out, there we are subtracting. Trying to think what else I'm at. That's my phone. I will put that on mute. Oh, maybe negative exponents. Negative exponents just mean reciprocals. If you think of like x, or I could just use numbers, like 2 cubed is 8, 2 squared is 4, 2 to the first is 2, 2 to the 0. The pattern here is you keep dividing by 2 because you're losing a factor of 2. So that's why anything to the 0 power is 1. And if you keep dividing, those are negative exponents. So a half, a fourth, an eighth. And do you see how they just kind of reciprocate around that? Okay. So if I give you 5 to the negative second, you're like, oh, 5 squared is 25, but I'm reciprocating it. I'm flipping it, and that's a negative right there. Okay. So, you could be like with exponent rules, you could be like, well, what about, that? What's the answer? Well, you're dividing, so you're canceling, so you're going to subtract. 6 minus a negative 2, you have to do some integer work there. It's really a positive 8. And if you're like, well, why? It's because negative exponents really mean to flip it or to reciprocate. So if I take that negative exponent and I flip it, that means the negative's gone now because I flipped it to where it was supposed to be. And so I get 8. So you can kind of see how that all works. Negative exponents just really mean reciprocate. Simplifying radicals. Sometimes students have a hard time with this. They forget this. But the way I think about it is with something like this is take out the biggest thing that has a square root. So I kind of view it as these 2 factors. It's 4 times 5. The square root of 4 can come out. The square root of 5 is stuck. So this is 2 radical 5 would be the simplified thing. So a lot of times, underneath here will be a 2, a 3, a 5, a 7, something like that. So if you have like something like 800, all right, you might be like, oh, I could do 8 and 100. But the problem is 8 still has something that you could square root. So then you're like, oh, well, then I guess I could break it into a 2, a 4, and 100 maybe, right? So that's still 800, yeah. And then the square root of this is 2. Square root of that is 10. These are factors, so you're multiplying. So you get 20 square root of 2. Another way is to, try to take the biggest thing out. So be like, oh, if you can recognize that 400 has a square root, then you're like, oh, the square root of 400 is 20 with the 2 left over. So you're trying to take out a biggest square root. So again, if I have 32, I might be like, oh, I can do 16 and 2. This can come out. The 2 is stuck. And as far as rules with radicals, just remember that when you multiply them, so say I have, 3 square root of 2 times 2 square root of 7. Numbers with numbers, so 2 times 3 are factors, 6 radicals with radicals, which is 14. And that doesn't simplify because that's just a 2 and a 7. Neither one of those simplified, so that's not going to simplify. But if I had something like maybe 7 square root of 3, 2 square root of 3, all right, outside with outside, I get 14. But now I get the square root of what, 9? That does simplify. The square root of 9 is 3. So is that what, 42? Okay, so you do have to kind of check after you multiply outside with outside, inside with inside, check your radical. And it could be that it only simplifies a little bit. So if I come over here, if I have, say, 2 square root of 6 times 3 square root of 2, outside with outside, I get 6, radical 12. And that 12 is a 4 and a 3. Square root of 4 is 2. Again, we're dealing with factors. 6 times 2 is 12 with a square root of 3. Okay, so that's just kind of a quick review of that. Let's see, what else do we have? I'm going to talk about, rational equations. If you have a rational equation, probably the easiest thing to do is to clear the fraction. So if you have 3 over x plus, say, 4, plus 2 equals, say, -2, something like that. Your common denominator here, there's just a 1 here, is x plus 4. So I'm going to multiply everything by x plus 4. These cancel, so I get 3. This, you have to do the distributive property, 2x plus 8. And this is the distributive property, negative 2x minus 8. All right, and then to solve linear equations, you want x's on one side, numbers on the other. So I'm going to add the 2x over here. So I'm bringing that over. So those cancel. What do I have? 4x plus what? 11 goes negative 8. And then you want to bring your numbers to the other side so you can kind of see what's happening with your balance. I get negative 19. And then to get rid of multiplying by 4, the inverse is that. All right, and then with inequality, or not inequalities, with rational equations, you want to check because dividing by 0 is a big no-no in math. So if I sub that back in, I can see if it works, but I can also see if, like, if this was a negative 4 down here, subbing a negative 4, you're dividing by 0, there'd be no solutions. So if you need another video on that, let me know. And then solving inequalities, if I have 2x plus 8, say greater than 10 or something like that, subtract 8 from both sides because we solve by doing the inverse. And the inverse of multiplying is dividing. And I get that. In interval notation, then, I would put an open dot at 1. So a lot of times in pre-calc, we would use a parenthesis because you can't land on it. You can get close to it. You can't land on it. And we want greater than. So we're kind of shading this way. So interval notation is where you start and when you end. So I start not equal to, but getting close to 1 and going off to positive infinity. And you can never land on infinity. Another example would be if I give you, like, say, negative 2x plus 3 less than or equal to, say, I don't know, whatever, it doesn't matter, 9. Okay, so subtract my 3 from both sides, keeping everything balanced. Now, when you divide by a negative 2, you have to remember to flip the inequality because you're kind of doing the opposite. So the opposite of that, opposite of that, opposite of that. Get negative 3. All right, so on this one, I have negative 3. This one can land on it. So in high school, you might have done something like that. Greater than a negative 3. So I guess we're still going to the greater side. A lot of times, we will use a bracket because you can land on it. You're touching it. It's flat, going off to infinity. So my interval notation is negative 3 all the way to what? Positive infinity. Again, you can never land on infinity. All right, that is my quick Julie notes for the review. And that's what you need to submit on in Canvas. Again, if you need detailed notes on something, please let me know on an individual basis, and I will send them to everybody. But this is what I need your Julie notes on. So, all right, great job. I will talk to you soon.